This is the third problem, D2.29. And given this closed loop gain of minus 500 volt per volt and using resistors less than 100k ohm, in part A we need to find R and this two resistor circuit here and the input resistance. So we need to meet these criteria here. We obtain this closed loop gain and use only resistors that are less than 100k. So for this particular circuit, we know if we consider ideal op-amps, we know that the voltage transfer function, so AV, is equals to minus R2 over R1. And that should be equals to 500, right? So, or minus 500, right? So that's minus R2 over R1. Now, if we need to get like this 500 here, so it's a large value, right? If we think of the magnitude, this R2 should be equals to, it should be greater than R1. So let's pick R2 equals to 100k, which is the maximum value that we have. So if we pick R2 equals to 100k, then R1 is equals to R2 divided by 500, and this gives us R1 that is 200 ohms. Okay, so that's the first answer. R1 equals to 200 and R2 equals to 100k ohms. Okay, so let's put ohms here. Now, how do we calculate the input resistance? So the input resistance is the ratio between VI over II. Now, if we look at this circuit here, because it's ideal, this is 0 volts, this is also 0 volts, right? V minus equals to V plus. And to calculate this, this input resistance, first we know that VI minus, so this potential here minus the potential here, so minus 0, is equals to that input current times R1. Now if we isolate this ratio, VI over I1, we get that is equals to R1. So in our case, the input resistance, our input, is equals to R1, that is 200 ohms. For part B, we have this 4 resistor circuit, right? So this 4 resistor circuit, the voltage transfer function is defined by this equation here. So I have it here, okay? And we need to define the values of R to get the smallest R possible. So one thing is that they all should be less than 100k, right? Equals or less than 100k, and we should get the smallest R possible between the configuration. So we can pick like R1, R2, R4 equals to 100k and then define what's the value of R3. We can pick R2, R4, R3 equals to 100k and then define the value of R1. So you can make all the combinations possible here to see which one gives you the smallest R. Now one thing is that if we pick, so let me write here, R1 equals to R2 equals to R4 equals to 100k, and basically we know that this gain here should be equals to minus 500, right? So if we isolate R3 in this equation, so if we just substitute here, we get that 500 should be equals to 100 divided by 100k times 1 plus R4 is also 100k divided by R2, which is also 100k, plus R4, which is 100k, divided by R3. Okay, so in this equation here, so this one here is 1, this one here is 1, and if we isolate R3 here, we get that basically 500 is equals to 2 plus 100k ohm divided by R3, and now we can isolate R3, so R3 is equals to 400k divided by it's not 400, is 100. Yes, 100k divided by 488 498. So 498, and that's approximately 200 ohms, right? So that's the best combination. If you look at the combinations that we have, I mean, we could pick like either, so let me see, because R3 here is the independent one, so it just appears here in the equation, right? So if you pick like R2 equals to something that it's smallest, you would probably won't get a smaller value than this 200 ohms here, okay? So if we now we need to calculate the input resistance. So the input resistance, remember the input resistance. So let me, the input resistance, VI over I, that's the input resistance, right? In our case, again, if we consider ideal op amp, this is 0 volts, this is also 0 volts. So we have the same equation. So if we pick like VI minus 0, that should be equals to I1 times R1, and this gives us this ratio that it's VI over, say, I1, that's equals to R1. So in this case the input resistance is also equals to R1, and our input resistance is equals to 200 ohms, okay, which is the same input resistance that we got, the smallest input resistance that we got from the previous circuit.